Okay, let us see this example. So, two bars AB and SC is mostly jointed at A in order to make a frame of a tent. So, they are jointed at A. So, this is A. So, the bars are AB. So, this is going to be AB. Then AC. AC. Okay. To make a frame of a tent. B is joined by a light rope to the midpoint of C. So this is our midpoint of C. So this is joined by a rope to that. So now I'm also going to the midpoint of a C. So that's what I'm going to be having. It's joined there by a rope. So that's my rope there. Okay, the midpoint there of AC, and the bar rests with B and C on a smooth plane. So if they are resting on the plane, it means we are going to have a reaction at B because there is contact with the plane. Also reaction at C because there is contact with a plane. Okay. They are telling us that an SC on a smooth plane. If angle BAC, so they are giving us this angle here as 60 degrees, okay? And the bars are 4 kilograms and 2 length to L. Find the directions at B and C, tension in the spring. Okay, first of all, because this one, they are having weight of 4, means that weight is going to act in the middle there. So it's going to act like this downwards. So to get the weight, we get the mass because it is 4 kilograms. We get the mass times D. So this is going to be 4 times D. Now this one is in the midpoint of SC. There is also weight. It's going to act. That's it's going to be 4 times D. Now, because this tension is pulling this side, means that our tension is going to be in the side. So it means that we're going to have tension there. Let me show you that example here. I don't know where I'm putting there. Anyway, because we have tension, it's going to be pulling this side. And then remember, this one we are joining it. So it's going to be pulled, but also pulled in that direction. So we are going to expect some tension in this direction. But also because this one is going to be pulling, we can also be having tension that side. So that is the tension in the spring there. Okay, then we are having that, I think that's all. So the length are 2L. So this is L because these are uniform rods. Means that this is dividing, this is acting in the middle. So also this is going to be L, and this is going to be L. Now, because this and this are the same, and this is 60, it means that this one is also going to be 60, and this one is going to be 60. Hence, we are forming an inverted triangle. So this one now is also 60, but we are going to divide this into 30 degrees, and also this one is going to be 30 degrees with it. So basically, now we need reactions at A and B. So it means that we need these distances. So now I divide this into 2 equal parts. So that I can get the length here, and here. So because I have this as 60, of course the surface is smooth, so we don't expect anything like friction. So because I know from here up to here is L, and the other angle is 60, so this one is going to be L cos 60. Now we say from here up here is the same as from here up here, so this is also L cos 60. So now the whole arm, so that I can use this because from here up here is 60, so that's why I'm using this. Here now is also going to be L cos 60. From here up here is the same as from here up here, so this one is also going to be L cos 60 degrees. Okay. Now what is going to be our height from here up to here? Because this is 2L, I think we see L plus L to L. So the whole is going to be 2L, then sine 60 degrees, because this is opposite to this, the same there. So basically that's what we have. Then I think we need now to get the reactions. That's all we had to put there. So to get reactions now, say the first resolve vertically upwards. Upwards, I have RB plus RC equally, those are the only forces acting upwards. Downwards, I have form D plus form D. So meaning that now my RB plus RC is going to give me 8G, and this is going to be my equation 1. So to get one of these, you take moments either here or here. But then you take moments here, so that this force, because I'm seeing this force, this one has many forces. 1, 2, then 3. This one has only a basically. So I better take moments from here so that I can kill off even that force. I don't want it. So take the moments at B. I'll get this one. I think this is anti-clockwise or anti-clockwise. So meaning I'm going to be having now RC times the perpendicular distance from here up to here. We add this L, this. So we have 4L cos 60. It's the only force. All forces from here, they are going to be zeros. So all forces from here, they are going to give us 0 moments. Because the perpendicular distance from here is going to be 0 to these forces. So this is 0, that is also 0. As simple as that. Okay, then those which are acting the anti-clockwise, these are acting now clockwise. We have this, then we have that one. So this one, first of all, from D times from B up to the distances L cos 60, then plus from D, this one times from here, we add here, you get 3L cos 60. I think it's that L cos 60 is common. We'll relax it. It's that this one we have now 4LC equaling 2. This is going to be 12 plus 4, which is going to give us 16G. So that my LC is going to be 4G, which you can put your G into, so that this is going to be newtons. From here, I can get now from 1, I can start my RB is going to be 8 minus RC, which will be 8B minus 4B. And now my RB is also going to be 4B newtons with ease. You see, very easy to get. Now, tension in a spring. Now, to get the tension in a spring, now that one we are going to separate. So now we are going to separate this diagram, and then you see that now our at A here, because there is no not force at A, that reaction is acting in that direction, and the reaction is acting in that direction. Now, I think it's that this and this, the net force here. I think this is our RB is 4, then RS. So it means that our vertical component, if you separate this side, then your R is going to be this side. If you separate this side, then your R is going to be this side, this side. So now I say separation. After the separation. So now let me consider on this side here. So when I separate to the left, this is going to be my reaction. My reaction is going to have components in that order. If you consider this, it will be adding up and then like that. That's why I said they are equal but opposite. So if I consider this one, now this is the case I'm going to be with. That's what I'm considering now. I'm having this like this. So this angle here, the whole of it, L is 60. So this is my B. So this is my reaction at B. Then this is going to be my A. So this A here, we are going to be adding horizontal component, which are going to call Rx, because our reaction is going to be in that direction. Then we are going to be adding Ry, acting downwards. Of course, we have a weight of 4B acting in that order. Then from here, I think we know that we have a certain tension T in our string, but you know that this is going to be 30 degrees, this is going to be 30 degrees. Now I think you see that we are going to resolve that tension there. So if you have resolved it, we are going to resolve it going in this direction, then upwards, like that. So we are going to resolve it, that tension, I'm going to resolve it in this direction, then I also resolve it going upwards. Or I can put, let me get like show you there. Okay, as I was telling you now, to resolve this T, we base on the angle it makes with the horizontal. So this one is going to be T. You see this is an adjustment, so it's going to be T cos 30. Then this one, the vertical component, is going to be this side line. This, let me use the line so that we don't forget that. So this is our T. Now you see it's going to be opposite, so T opposite goes with sine 30 degrees. So basically those are the forces we have. But this is from this, it's from B here, because it's already there. So basically that's what we have. So what we say, you resolve horizontally, you see we have T cos 30 degrees. It's the one acting this side. Because this is in equilibrium, this is going to be equal to that. Those are the horizontal forces we have. Because of our friction is equal to Rx. So meaning my Rx here, you see this one is going to be root 3 over 2T. I call this equation 1. Then if I resolve vertically, we have this. I think it's the only force going upwards, and this we have T sine 30 degrees, then plus RB. There are the two forces going upwards. Now this is going downwards, and this one. So you have 4B, then plus RY. Remember we have this RB, so this one is going to be T, or times half. Then plus RB is 4B equaling to 4B plus RY, implying that our RY is going to be T over 2. So I call this equation 2. Now, after that, then we take moments at B so that we can get Rx. Okay, so take the moments at B. Now you see, we want this one, so I'm going to take them anti-clockwise. Or from here, anyway, whatever. So take the moments at B. Now, when you look at B, all forces from B, their moments are going to be 0. So you see this one is from B, this is from B, and this is from B. So the only forces surviving, this, and this. They are the only forces surviving. So, anti-clockwise, I think you can see anti-clockwise, this is anti-clockwise. So we have Rx times the perpendicular from here up to here. Remember, this is the distance here if I have to complete. Now, the perpendicular from here up to here, we have seen it's the same from here up to here, which is, the whole of this is 2L sine 60 degrees. So the perpendicular from here up to here is the same as from here up to here. From the point where I take the moments from, so this would be 2L sine 60. It's the only, I think it's the only force acting anti-clockwise. The rest, clockwise. I think you can see. If I come to this, you see it's going to act clockwise. Even RY clockwise. So I have 4D times the distance from here up to here. I think you see from here up to here is still RL cos 60 degrees. So L cos 60 degrees. Then plus this one, the perpendicular distance we have the force as RY. The perpendicular distance from here up to here, I think you see. I'm going to add this L, even this is L cos 30. I add this and this. From here up to here, same as 2L now cos 60 degrees. So now, you know this is going to be Rx times 2L times sine 30, and then sine 60 is root 3 over 2 equaling 4B times L times cos 60 is a half plus our Ry but our ry is what? By the way, even our rx is known. Where is my duster? Please. My duster, you are getting lost. Anyway, let us leave that. Okay, I'm going to, but this one is t. Okay, ry times 2l times a half. But my rx in terms of t is there. So I have root 3 over 2t times, now you say, I think this one is going to simplify with that. You see l is common, l is common, l is common. So there I have now on the root 3 the r x root 3 over 2 times root 3 equaling 2 here by this 1 by this 2, so I have 2g, then plus rt in terms of t. Then I think we see this one is going to simplify with this. Simple. So root 3 times root 3, I'll be having 3t over t, then minus t over equaling to 2g. I think we see when you simplify that, 1.5 minus 0.5, we get 1. So it's that from there. By simplifying this, we get 3 minus that will be adding our t equaling 2g. It's so after getting that, now you can eliminate first my duster. Okay, now from here, I think you can only see. Okay, so now after getting my t, of course it's going to be in newtons. That's my t. So after getting t, I can get my rx. So my rx, which is given by, it's going to be root 3 over 2, then t, so it's going to be 2b. This one and this one cancels, so my rx is going to be g root 3 newtons. Simple. Then ry, right, is going to be, oh, this one is from equation 1 there. My ry from here, see it's given by t over, so it's going to be 2g over 2. So my ry is going to be g newtons. As simple as that. So they wanted us to get the magnitude, so I think you can see our magnitude from there. Our r is given by this, a reaction at A. So this is Rx. This is going to be Ry. This is going to be our R. So our reaction there is going to be the square root of Rx, which is g root 3, the whole squared, then plus g squared. And from there, so that our reaction here is going to be, I think you see this is going to be g, but it's giving me 2g. Because you see this squared, we pull it out, I have 2g. So I'm getting this as 2g newtons, which is. Okay, then they want us to get the direction in which it's occurring. Okay, let us call this angle theta. Let us call this angle theta, where it's occurring. Let us call it theta. So you see that the direction, you can able see that now my tan theta is going to be the opposite, which is Rx. This is the opposite, Rx, over the adjacent Ry. I'm setting it to the vertical, horizontal downward. So my theta is going to be now tan inverse Rx. Rx is what? Is d root 3 over Ry, which is g. And from there, I can say my theta is going to be 60 degrees. Therefore, reaction is 2g newtons at 60 degrees downwards. Why am I saying downwards? Because that's my angle, I set it downwards. So basically, that's what we had to get. Or if you set it here, that's going to be 30 degrees. Today I need to the left, or eastwards, or to the end. So that's it, members. I wish you best. Now, if they give you G in the question, or at the front of page of the paper, get this G, remove this G, remove this G. Any G where when you are given G, remove the G. In most cases, it's 9.8. Period. So that's it. Me, I'm not removing because it's my question. I don't have G. I'm just leaving it like that. But if the question they give you in the front of at the front page, don't leave the G in there. That's it. I wish you well.